Hello students and welcome to Smartkidz tutorials. In this video we will be solving 10 MCQ questions on trigonometry from the NCERT exemplar book. So let's begin. First question says if cos A equal to 4 upon 5, then the value of 10A, and the choices given are 3 upon 5, 3 upon 4, 4 upon 3 or 5 upon 3. So let's begin by solving based on what we have been given. We have been given cos A is equal to 4 upon 5, which means cos, as you know, is base upon hypotenuse. So if we draw a small triangle, a rough triangle this way, okay, and let's say this is our angle, okay, which is let's say A, and this is right angle over here. Then in that case the base would become this one, and this would be the perpendicular, and this would be our hypotenuse opposite to the right angle. Now base we have got as 4 from what we have been given, and so 5 would become the hypotenuse. If we want to find the perpendicular, so we use the Pythagoras theorem, and then according to the Pythagoras theorem it would be finding p square, that is perpendicular square of the perpendicular, would be equal to the square of the hypotenuse minus the square of the base. That would give us square of hypotenuse is 5. So 5 square minus 4 square, that would be 25 minus 16, that would be 9. 9 is p square, that is square of the perpendicular. So that means perpendicular will be equal to 3. We are asked to find out 10A. So 10A is perpendicular upon base. So perpendicular we have found as 3 and base we had got as 4. So the answer is 3 upon 4, and in this case the answer would be, correct answer would be B, 3 upon 4. Question 2, given that sine theta equal to A upon B, then cos theta equal to dash. Okay, so in this case once again we start with what we have been given, that is sine theta equal to A upon B. So sine theta equal to A upon B, and sine is perpendicular upon hypotenuse. So if we draw a rough triangle once again this way, okay, and make this as the angle that we need, that is theta, okay, then in that case this would become our perpendicular. Of course this would be our right angle, this would be base, and this would be hypotenuse. Now sin theta, it says, is A upon B. A is perpendicular, so this would be A, and hypotenuse would be B, this one. So we need to find the base. So by Pythagoras theorem, base square equal to hypotenuse square minus perpendicular square, and hypotenuse is B. So B square minus P, which is A, so A square, that is B square. If you want B, that is the base, and that would be square root of B square minus A square. What we need is cos theta. So cos theta is given by base upon hypotenuse. Base is square root of B square minus A square, and hypotenuse we got from here as B. So the correct answer would be C, square root of B square minus A square upon B. Okay, correct. This one. Moving on to the third question, if cos of alpha plus beta equal to 0, then sine of alpha minus beta can be reduced to, the choices given are cos beta, cos 2 beta, sine alpha, or sine 2 alpha. Let's begin with what we have been given. Cos of alpha plus beta is equal to 0. We also know in this case that cos of 90 degrees is also equal to 0. So from these two we can say that alpha plus beta is equal to 0. If you do not know how to get that, it is cos alpha plus beta is equal, we can write this 2 as cos of alpha plus beta equal to cos of 90 degrees. Cancel this part, we get alpha plus beta equal to 90 degrees. Okay. Anyways, so alpha plus beta can be written as equal to 90 degrees, and we can also say that alpha is equal to 90 degrees minus beta. We'll come to know why I'm taking this later. So let's begin with what we need to find, that is sine of alpha minus beta. Okay. Now there's nothing else that we can take from here apart from the fact that we have got alpha equal to 90 minus beta. So I'm going to put that value of alpha over here. In place of alpha, I'll put 90 minus beta. So if we do that, we get sine, instead of alpha I put 90 degrees minus beta, and this minus beta, do not forget that one. So minus beta and minus beta will give us sine of 90 degrees minus 2 beta. Okay. Now this is a type of complementary angle, okay, where 2 beta is an angle. So sine of 90 degrees minus 2 beta can be written as cos of 2 beta. Complementary of this is cos 2 beta. So we have that in our choice over here. So B is the correct answer, cos 2 beta. Next question, question 4. If cos of 9 alpha equal to sine alpha and 9 alpha is less than 90 degrees, okay, so it's pointing out to the fact that we need to consider taking complementary angles at some point of time in this for solving this question. Then the value of tan 5 alpha is one of these, that is 1 upon root 3 or root 3 or 1 or 0. Let's begin with what we've been given. So cos of 9 alpha equal to sine alpha. Now cos of 9 alpha, since we have been given 9 alpha is less than 90 degrees, that means part of the complementary system. So we can take cos 9 alpha, we can write it, the complementary of cos is of course sine, but to write it we'll have to do it this way, sine of 90 degrees minus 9 alpha, okay, because sine of 90 degrees minus 9 alpha is cos 9 alpha. Why we are doing that, we'll come to know. So this is also sine, this is also sine. We get rid of this, we are left with 90 degrees minus 9 alpha equal to alpha on this side. So I'll take 9 alpha on this side, it will become positive and we'll get 10 alpha, alpha plus 9 alpha. 10 ones are 10, 10 nines are 90. That leaves us with the value of alpha, which is 9 degrees. Now we have asked to find out tan 5 alpha. So tan 5 alpha. Now in place of alpha, we'll replace it with this value which we have got for alpha. So tan of 5 into 9 degrees, and that would be tan of 45 degrees. And tan of 45 we know is 1. So the correct answer is C, that is 1. Question 5. If triangle ABC is right angled at C, then the value of cos of A plus B is either 0, 1, half or 3 by 2. So triangle ABC is right angled C. We are not given much, so we'll work with whatever we have been given. If it is right angled at C, so it is over here, and one of them has to be A or B. I'll take this as A, I'll take this as B. You can take even this as A or B, it's up to you, you can interchange. But C has to be here because it says it is right angled at C. Now we are asked for the value of cos of A plus B. Now when it is right angled, no, this is 90 degrees. We know the sum of the angles of a triangle is 180 degrees. If this is 90 degrees, that means this plus this has got to be 90 degrees. So if I take this angle as theta, then this has got to be 90 degrees minus theta, because the sum of this and this will give us 90. So if this is theta, we have to take this as 90 degrees minus theta. Okay. So we are asked for cos of A plus B, right? So which is equal to cos of A is 90 degrees minus theta and B is theta. So A plus B, this is A and this is B. So A plus B, 90 degrees minus theta is this, plus theta, which is B. So minus theta plus theta will give us 0, cancels out each other. We are left with cos of 90 degrees, and cos of 90 degrees we know is 0. Therefore our correct answer is A, 0 for this question. Sixth question, if sin A plus sin square A equal to 1, then the value of the expression cos square A plus cos raised to 4A is either 1, half, 2 or 3. So we begin with what we have been given. Sine A is equal to sine square A, we'll cancel this, sine A plus sine square A equal to 1. What I'll do is I'll take sine square A on the right hand side, and we get sine A equal to 1 minus sine square A. So sine square A, which is positive, when it goes to the right hand side, it changes sign to become negative. We know 1 minus sine square A is cos square A. So sine A equal to cos square A. Okay, we will keep this way because it will be useful for us. We continue with what we have been asked. So we are asked to find out the value of cos square A plus cos raised to 4A. So cos square A plus cos raised to 4A. And I'm going to change this cos raised to 4A. We can write this as cos square A the whole square. Okay. So when you open the bracket, it becomes cos raised to 4A. Now cos square A we have got as sin A. So I'm going to replace it with that. So cos square A, instead of cos square A, I'm going to write sin A. Okay, and do not forget this bracket, which is square. So this gives us cos square A plus sin square A. So I'm removing the bracket. And we know that cos square A plus sin square A is equal to 1. So that leaves us with the answer 1, that is A is our correct choice. Question 7. Given that sin alpha equal to half and cos beta equal to half, then the value of alpha plus beta is, choices are 0 degrees, 30 degrees, 60 degrees, 90 degrees. Sin alpha is half. We also know that sin of 30 degrees is also half. Okay. That means alpha should be equal to 30 degrees. Similarly, cos of beta is given as half, and we know cos of 60 degrees is half. That means beta should be equal to 60 degrees. Now we are asked to find the value of alpha plus beta. Alpha plus beta. Alpha is 30 degrees and beta is 60 degrees. That means alpha plus beta should be equal to 90 degrees. So our correct choice is D, 90 degrees. Question 8. The value of the expression sin square 22 degrees plus sin square 68 degrees upon cos square 22 degrees plus cos square 68 degrees plus sin square 63 degrees plus cos 63 degrees sin 27 degrees is either 3, 2, 1 or 0. When you look at such a big expression, do not get nervous or do not get overwhelmed. Whenever you have a big expression like this, chances are that either they will get cancelled or reduced to very, very small numbers. As you see, the choices themselves are showing you that how small it will get reduced to. So look for combinations that will reduce them to as small numbers as possible. What I see over here is this is sin square 22, sin square 68 degrees. Now, can we change one of these to have the same degrees? That means, but with complementary angles. Okay. So what I see over here is that we can change this from sin square 22 degrees. We can change this to cos square 68 degrees. Because if we do that, then cos square 68 degrees and sin square 68 degrees will become 1. Same thing if we do here also, it will become 1 upon 1. And here if we have a look, this is by itself sin square 68 degrees, so we can't do anything. But over here, if you look, there is cos 63 degrees and sin 27, and definitely we can get a complementary way. If we've got sin square, can we convert this to cos square by changing this sin 27 to cos 63? Then cos 63 into cos 63 will give us cos square 63 degrees, and sin square and cos square with the same degree will give us 1. So I've almost solved the problem orally. Let's do it here to understand what I was talking about. So I'm going to change the sin square 22 degrees in another way. I'm going to write it differently. First, let me repeat the question. I mean, sin square 22 degrees plus sin square 68 degrees whole thing upon cos square 22 degrees, and I'm not going to put this bracket, plus cos square 68 degrees plus sin square 63 degrees plus cos of 63 degree sine of 27 degree. Okay. Now, I'm going to write this sin square 22 degrees as sine of 90 degrees minus 68 degrees. 68 plus 22 gives us 90. So we can definitely write it as a complementary. And I'll put this as sine square 90 degrees minus 68 degrees because there's a square. And I'll keep this sine square 68 degrees the way it is. Then same thing I'll do over here. Instead of cos square 22 degrees, I'm going to write it as cos square 90 degrees minus 68 degrees. Whatever I've done here. Plus cos square 68 degrees. I'll keep this in sine square 63 degrees the way it is. Cos 63 degrees also same. But sine 27 degrees, I'll change it from sine 27 degrees to sine of 90 degrees minus 63 degrees. Okay, fine. Okay, moving further, sine of 90 degrees minus 68 degrees can be written as cos of 68 degrees. So because it's a square, I'm going to put a square here. Plus sine square 68 degrees. So do not miss out on what is already existing. So do not forget that. Cos of 90 minus 60 degrees, 90 degrees minus 68 degrees can be written as sine of 68 degrees. And I'm going to put a square over here because of this. Plus cos square 68 degrees. Next, plus sine square 63 degrees. I'm going to leave it this way. Plus cos 63 degrees. No change here. But sine of 90 degrees minus 63 degrees can be written as cos of 63 degrees. Now mind you, these two are multiplication. There is no sign between them. That means they are multiplied. Cos square 68 degrees, sin square 68 degrees and sin square 68 degrees, cos square 60 degrees, they are the same, so they cancel out and we are left with 1. You can solve for them individually also in the numerator and denominator. Cos square plus sin square gives us 1, cos sin square, cos square gives us 1. See, cos square, sin square can only give you 1 if the degrees are the same. So in this case, it's 68 degrees both places, so that will give you 1. Same thing applies for this. Degrees are the same. Either you cancel out both of them or you can solve for the numerator and denominator separately. If you solve for the numerator separately and denominator separately, you'll get 1 upon 1. If you cancel them, it's just 1. Anyways, 1 upon 1 is always 1 only. Plus sin square 63 degrees plus cos 63 into cos 63 gives us cos square 63 degrees. So 1 plus sin square plus cos square of the same angle gives us 1. And that gives us answer 2. So the correct answer is B, 2. Ninth question. If 4 tan theta equal to 3, then 4 sin theta minus cos theta upon 4 sin theta plus cos theta equal to that. And the choices are 2 upon 3, 1 upon 3, 1 upon 2 or 3 upon 4. 4 tan theta equal to 3. I'm going to write this as tan theta equal to 3 upon 4. And tan theta can be written as sin theta upon cos theta equal to 3 upon 4. Let's not touch this, leave it over here. We'll move on to what we need, that is 4 sin theta minus cos theta upon 4 sin theta plus cos theta. What I'm going to do here is I'm going to multiply the numerator and the denominator throughout by cos theta, and if we do that, this is what we'll get: 4 sin theta upon cos theta minus cos theta upon cos theta. This is only for the numerator, okay? Remember the minus sign also, and it is only for the numerator. For the denominator, I'll put a equal to sign here, the fraction line here, and 4 sin theta upon cos theta plus cos theta upon cos theta. Okay, so I've balanced numerator and denominator by by dividing cos theta in the numerator as well as denominator, and it applies for each of this fraction. So in this case, we'll write for top sin theta upon cos theta we have got as 3 upon 4. So I'm going to substitute that. We write as 3 upon 4 this cancels out, and so also this cancels out. Okay, and we will be left with 1 here, and in the denominator, same thing, 4 into 3 upon 4 plus 1. Okay, 4 and 4 cancels, and I'll just solve it here. We are left with equal to sign 3 minus 1 upon 3 plus 1. So this 3 is left in the numerator, 3 minus 1 and 3 plus 1. That gives us 2 upon 4. 2 ones are 2, 2 twos are 4. We are left with half. So the correct answer is C, half, for this particular question. Coming to the final question, which says if sin theta minus cos theta equal to 0, then the value of sin raised to 4 theta plus cos raised to 4 theta is 1 or 3 upon 4 or half or 1 by 4. Let's see. So when I look at the sin theta minus cos theta, the first thing equal to 0, first thing that I can see is if I take minus cos theta on the other side, we'll get sin theta equal to cos theta. Now straight away we can't use this, but at some point of time we will be able to use this. Okay, and we'll see when. I'll continue with this expression here, sin theta minus cos theta. I'm going to write it again, and what I'm going to do is I'm going to square on both sides. When I square on both sides, this is what I get, sin theta minus cos theta as a whole. I have to square, it becomes squared, and 0 whole square. 0 whole square is 0 only. But here in this case this becomes a minus b whole square. So a minus b whole square, if we expand this identity, it will be a square plus b square minus 2ab. Okay, where a is sin theta and b is cos theta, equal to 0. The sin square plus cos theta, sin square theta plus cos square theta is 1. Okay, and I'll take this minus 2 sin theta cos theta on the other side. When I do that, it becomes positive. So we get 2 sin theta cos theta equal to 1. Now this 2 sin theta cos theta means 2 into sin theta into cos theta, multiply. If I want to bring 2 on the other side, it will go into the denominator, get divided. So we'll get something like along these lines, sin theta into cos theta equal to half. Half from where this 2 comes down, it will become 1 upon 2. Okay, sin theta cos theta. Now we know that sin theta is equal to cos theta. So instead of cos theta, I'm going to replace it with sin theta. So sin theta into sin theta equal to half. That gives us sin square theta equal to half. If I square on both the sides, this is what I'll get, sin square theta square and half square. Then we'll get sin raised to 4 theta equal to 1 upon 4. Now we know that sin theta is equal to cos theta. So similarly we can write also cos raised to 4 theta is equal to 1 upon 4. Why? Since sin theta equal to cos theta. Where we found this? Over here. Now we have been using this a number of times. Here also we use this over here. Why? We replace cos theta with sin theta. Why? Since sin theta equal to cos theta. Where we found this? Over here, same arrow. Okay, so now we know sin raised to 4 theta is equal to 1 upon 4, cos raised to 4 theta is equal to 1 upon 4. What we were asked to find the value of sin raised to 4 theta plus cos raised to 4 theta. So let's do that. Sin raised to 4 theta plus cos raised to 4 theta is equal to 1 upon 4 plus 1 upon 4. We found the values here. Now 1 upon 4 plus 1 upon 4 gives us half. Okay, so the correct answer in this case is C, half. Okay, so with this we complete this set of MCQ questions. Okay, I hope you have been able to follow exactly what has been done over here, and it has been beneficial for you. So if you have liked watching this video, please do hit the like button, share it with your friends as well as your classmates. If you haven't subscribed, please do subscribe to the channel, as more such videos will be coming along the way, and keep watching for more such videos. Thank you for watching. Keep watching.